Hey guys, going to update the terrain pathfinding system on this video. Finally got that to work. It is a complex issue and took me a little while, but I got it. Say for example you've got a big level like this. It actually is quite, from a terrain's perspective for CopperCube at least, it's fairly good size. Say if you've got a terrain and you want to move from A to B, so you'll have a start and end position. So this will be for your enemy AI to move from one place to another, typically. So there's the blue square, that'll be the start position. That yellow one at the far end will make that as the end position. So it's got to wind itself around the mountains and all the rest of it. And also, I wanted it so it would follow natural curves or depressions of the terrain. So it's not going to just walk over a high mountain angle. It's going to take a lower angle approach as a general rule to work its way around things in a more natural way to move from A to B. Now the terrain system in CopperCube, it's made up of a ton of lots of little cells, which is a little square, two triangles, and so it's already really set up for a two-dimensional algorithm like A star or other types of things to look at. But you wouldn't use A star for this, I don't think. There's too many paths. There's 290,000 individual cells. For A star to work properly, it's got to check every single path, and then basically that's on the entire level, pretty much, or at least in a very large general vicinity, and work out the best path from all of those paths. I think that would just take too long. So I've manually relied on the closest next path from the starting position heading towards the end position. But not only that, it also looks at the average angle change, so the change in height divided by the distance of the next path that you're looking at, and it's got to say, is that within a certain angle? So it's basically an angle ratio between the height and the distance, and so that ratio, it's got to be below a certain maximum height ratio, otherwise it's too steep to go up or down to the next path in the cycle. And then on top of that, so there's the total distance. And the next distance has a maximum movement as well from the current position to the next position that it's allowed to move. So you don't want to take massive jumps. It wants to be within reasonable distance, but not necessarily super close either. So basically what I ended up doing is dividing the whole terrain into a square grid made up of 7 by 7 squares or cells, and only checking the 5 by 5 in the middle of it, so it's got a two cell edge gap. I did that to try to avoid duplicated cells, so that if two 7 by 7 grids side by side, you wouldn't have like two cells right next to each other, because sometimes that would happen, and you wouldn't need two, you only need the one. So that worked out pretty well, so I'll show you that. So that's an example here, dividing the terrain up into blocks of 7 by 7, and the blue colour here is just the 5 by 5. The green is actually the lowest point of each of those blue grids of 5 by 5. So it's not just the lowest angle. That didn't always work out so well. I found the lowest height, vertical height, worked out a lot better actually. And when I'm walking through the terrain, working out the path, I'll look at the angle then. But yeah, so that's basically what I did. Okay, so there's our terrain. I've created the lowest found cell on each of the 5 by 5 grids throughout the whole terrain. If the angle is within, at the lowest point, if that angle is below a certain point, then create the little green squares, the green cells. So you'll see most of the mountains don't have anything, because the lowest level was probably like on a side of a hillside, so that it's way above a minimum walkable angle. So yeah, so that's good. So we don't want to be looking at that. Now I've also limited I created for the entire terrain, and then I created another array. So you see that at the top right, the information says, so it's 240,000 individual cells all up. That's a lot. And then immediately I break it down to In the 5x5 cells, I just pick one of them. The lowest point that has a correct angle of the 5x5, I just grab with the one. And that in the terrain is 2,800 cells. And then I further narrow it down to another array, which is only looking at the cells between the start and the end position, and a little bit of side distance buffer in case you've got to walk around things to get to it. Hopefully, in most cases, that should be wide enough. It's possible it might not be sometimes, but that's how it is at the moment. So you can see it's been cut off on the left, on the right. It's got a little bit after the end of the position and a little bit before, between the start and the end position. So we're just looking at those cells. So that's we've got that down to 925. It's still a little bit high, but each sequence, as I do it, I'm getting the array size down lower and lower, and it just so in other words, this setup of the terrain with all these little green potential path nodes is you set it up before you run your game. You need to run it once. It'll then filter it down just the starting, the end position nodes it needs to look at, and then it can start to do its calculations. So I'll run you through that now. So I've got a lot of debugging messages along the way. It's quite a bit of work to do this to get it quite nice. You'll notice a few weird little things, but at the end of the day, you want it to find the path. That's really the main thing. Whether it's the most perfect path possible, well, I mean, that's not the main thing. It will generally be pretty good. It might be, a little bit off here and there, but anyway, this is how it is at the moment. If it's something you don't like about it, let me know. So you notice how the paths are fairly equally spaced. I had different ways of doing this before, but I found ultimately that's probably the best way to do it. Actually, if you notice here, so you see those two here, right there? They're fairly close together, but not too close. So that's why the two edge gap around the 5x5 in the 7x7 grid that I'm looking at, to try and stop duplications unnecessarily. So here's the blue one. Let's try and get to the end position. I've got it set up so you step through it one path at a time, but when I'm completed it for the user to use, it'll just be done in one huge fast step by the C++ code. So anyway, I'm just going to step through it to show you. Okay, so we've got 925 local nodes it's looking at, which is still quite a bit, but it's a lot better than 240,000. Okay, so it's found the closest node. So it's always going to find the node closest to the end position, that yellow one down there. That's by default. That'll be the main determining factor, but not the only factor. So in this case, it's found that one. Alright, so it's saying distance from start. I've got a distance from start. I've got of a maximum allowed distance. Then the end distance is a total distance. Angle Y is the angle of ascent or descent from the current position to the next position, and the maximum allowed at that point. And some of these numbers will change. So if it gets stuck and it can't quite find a path, it'll upgrade some of those numbers and have another look. But by default, it'll always try and find the best, the easiest way to get there without walking over a high mountain or something crazy like that. So okay, so this section here is what I call the discovery phase. It won't necessarily give the optimal path right now. It's going to go through a lot of different paths to find which path can it take to ultimately get to where it wants to go. So there will be a lot of testing of paths that don't actually work out, and then after all that's done, there's a cleanup phase. That's the final phase that only just picks out the most optimal route and just dumps all the other failed attempts that didn't go anywhere. So that'll be done later, but for now it's a discovery phase. So it's looking at, okay, the closest path. Okay, it says that the next path further ahead is too much of an angle to get to from where I am now. What's telling me right now, and that one on the right, it could have gone left, could have gone right. The one on the right, it would appear that it's just a fraction closer to the yellow end path down there than the one on the left. Either way, it'll all get worked out at the end when I clean it up. You won't see backward movements like that. It's doing a bit of a circuit, it's just finding any available left paths around that we can take. No, so we can't go down there. That's way too steep. We're not going to go down there. So that'll be the last time it looks down there. It says no path. Maximum move angle now is 250. I'm allowed to move, and I've upgraded the angle that it can move to 0.275 instead of 0.25. So that'll change over time. No, still can't find a path. All right, give me the maximum movement is 250. Now it's up to 0.3. All right, now I've upgraded the movement distance allowed is 300, and the angle is now 0.325. I've done it that way because the code is really weird. If you try and incorporate all of these checks into one simple line of code, it just does not work. It does not work like if you do an and minimum angle and minimum distance to the closest to the end position, and no, that is not going to work. You'll find that it just won't, because all those things have to be found to find the next path, and that causes a lot of issues. So I found this way works quite well. So now it's upgrading the maximum distance still. Okay, still can't move. All right, so it's found can't move, so we're stuck in a corner. Let's go back. Go back 2 places, and the maximum movement is now 350. All right, so now we're going back to the left. And the angle of movement, everything's okay, so we can keep moving. We'll try and have a look on the left now. It says, yep, so go here. All right, so that looks pretty good. So obviously we're not going straight off the cliff here because it's a bit too much of a descent. It's going to try and use, it's going to try and find the more, natural, easier path to follow. Even if it is a longer distance, it's a more natural way of moving around. All right, so yep, still good. Let's find that one. Okay, so it's moving back towards the final destination now because of the ones closest to the end position. These are the ones left to use, which are correct, which is the right ones to use. All right, so now we're moving. Yep, now we're moving, heading towards the final position. And what it used to do is, because it's by default, main thing determining factor is the closest distance to the next closest distance to the end position. What it used to do is climb up these angles of the walls and go up this way. I found a solution to stop that because I don't want it doing that. I want it to follow a more natural path, through caverns, through the bottom of caverns, and follow as you'd expect, like an animal or something would walk. It's not going to climb up halfway up the mountain. All right, so that one turned out to be okay. This one, not so much. I had to find an alternative path for this one because otherwise it would have gone here. So what I've got is the best optimal path based on closest distance. Then I've got the second best path. Every time it checks, it has an updated second best path. If the second best path is a much lower height than this one, it'll take the second best path instead, because it's a more natural way to move about. So it's taken that one, so that's good. All right, so now we're moving. Looks pretty good. Fairly natural movement going through the place, which is good. Okay, it's going to hug the corner a little bit here. Not too much, not too bad. Now you could argue that the paths, there's not enough paths, so that when it does find a path, it tends to zigzag a little bit. But when I do the final cleanup, things like this path here will be removed, and it'll just have those two instead, and it'll look more direct, a straight line. It won't be so bad. Okay, so all right, so now we're moving towards the yellow end path over there. Now we've encountered a bit of a hillside here. This is not really typical movement. We'd just normally go around that. I mean, you could change the numbers to walk straight over the top of it, sure. But you can, and by the way, a lot of these numbers you can change in the API. I'll have it so you can change the maximum default angle of movement and also the you know, and things like that. You'll be able to modify and tweak it to how you want. It'll change the pathing then a little bit. At the moment with 0.25, so that maximum of 0.25, that's the maximum or default ascend or descend angle of movement. So it's defaulted back to the basics. So in other words, it's going to go around that little mound there a little bit. Of course, you can change that, and you can just say, "Oh, forget about that. We'll just go straight over the top of it." You could do that. So you'd upgrade it to like 0.3 or 0.35, something like that. And also these right 90-degree angle, that you won't see that in the final cleanup, because it'll just dump that one there and go from there straight to there. It'll clean it up and smooth it out a bit. Okay, so but in this discovery phase, I prefer to have more cells highlighted and found, so that when I do the final cleanup, it's able to look at it at least and then say, okay, is that a good way to go to, or is that not? Because if it's not even in the array, it can't even do that check. It's not the most perfect way to get to A to B, but it will get there. That's the main thing. It's working its way around, and like I said before, when I do the final cleanup, it'll tend to remove sharp angles and smooth it out a lot more. And if you didn't like this, how it's going around this little mound here, you could just upgrade the angle from 0.25 to say 0.3, 0.35, and it'll probably just walk straight over the top of that. Won't be a problem. So it's highlighting a few more pink cells, but that's good, because in my final cleanup, I need to have that into the final data, so it can even, look at it, because this is not necessarily bringing the optimal path this stage here. It's like in discovery phase, it's checking a lot of cells, and some, a lot of them will be disregarded at the end. So, all right, so it's working its way around. It wants to go up there. Okay, so I want it to get there. All right, so by default, that's too steep for it to get to from there to there. I mean, it shouldn't really be. I probably should change it from 0.25, say 0.3 is probably better. So anyway, as it gets close to the final destination, you can see it's actually gone up already to 0.3. There's good. But from there, wow, that is a bit of an angle of attack. That's more than 0.3. That's quite high. But anyway, it'll still get there, because you'll see the numbers will go up. It's gone up to 0.325. Still can't get it with 0.325. Okay, so it's working its way back, but it's also increasing the maximum movement and angle that it's allowed to move. So it'll probably do a switchback from this point here, but that's okay, because it's in the cleanup phase. You won't even notice that. It won't be doing that in the cleanup phase. So there it is there. So it's moved 413 units, and it's moved up 0.34, an angle of 0.34. You might actually, is that 34%? Not entirely, possibly. Yeah, so now I can get to the final destination. It can either just go here, that's close enough, or that one there is close enough. So in my next path, it'll get there and then reset. You'll find. So I'll go one more. Yeah, it says okay, destination reached. You didn't actually see the final destination, but it got there. So it says the final array size before cleanup is 89. 89 individual like red paths in the second last array, and then it cleans that data up and puts it into another array, and it's got 52 paths. So it's cleaned up quite a lot. Got rid of a lot of junk, if you like, and you'll see that now. I'll just run the final path after cleanup and step through that one bit at a time. Okay, so now's the cleanup. The cleanup path's been cleaned up. It's removed a lot of unnecessarily paths too close together. It's a lot more inlined now, as you can see. So it's it's following the contours of the terrain fairly well. Doesn't want to go up there, so we'll go around there. So there it is there. There's Yonk. It does a few jumps around a little bit, which is not a massive problem. And then it cuts back to go around. had this been a different terrain, a bit lower, theoretically you could probably go up there, but that's a bit too steep, so I didn't find the path there. But yeah, so okay, so it's a little bit of a, obviously when you're doing the enemy AI moving around from one path to the next, you wouldn't go get to the final this next path and then change the next one. You'd say within a certain distance, if it's got to a certain distance of the next path, just go to the next one. So in other words, when you do that, it smooths out the movement, so you won't see left and right movement so much. It'll just smooth that out. That's how you would code it in JavaScript. So it would go from here, then there, then a little bit down here to a certain distance, and change over here, and then go around this way. That's still following, pretty much, sort of following the natural contours of the hillside reasonably well. I mean, you could argue I need a few more paths in there to make it a little bit more accurate. Oh, you could see how you go anyway. For now, it's not too bad. So there we go, we're working our way up. Boom, boom. So it's deleted all that old junk that was there before, and just clean that up. And there's pretty much the final destination there. Yeah, so when I try and go one more head, there's no more paths. It says last array, element 51. So that's close enough within the final destination for it to complete the path. Yeah, so that works. That's pretty good. And you can reposition, obviously, the paths, start and end path wherever you want, and it will do the same thing. This was a particularly long distance one. I'll change the starting path to somewhere else. This is a box. The actual position of the box is in the center of the box, so I need to make sure that the box is halfway in the ground, so that the center position is actually matching the ground level. Okay, got another one here. There's the blue there and the yellow's down there. We're going to go from A to B that way. All the little green nodes are highlighted in that whole box of an area. That can be used, and we'll step through that. Now, the default method is good for tight spaces, working around things, but in open areas and large flat grounds, because it's always trying to find the closest route, direct route to the final destination, it doesn't know there's a mountain there, so it has to feel its way around things in the discovery phase. It'll get cleaned up later on anyway, so all these extra nodes that don't quite make it will be removed, so that's fine. So frankly, the more red ones in this discovery phase is probably the better, because it has more options to choose from in the cleanup mode. Because if it skips ones like that just there, then if it's not red, it's not in the array, and if it's not in the array, it can't be used. Okay, so does a bit of a back out there, goes down here, goes around there. So it's always trying to make a beeline straight to the destination this way. I've got a better way where you're doing a lot of curving around things. I've got what's called main guide nodes, or guide paths, which will head it in a certain direction for a certain time. So it'll help it to guide it around things better. I'll show you that now. Okay, so I'll just quickly finish this path up. It's got the destination array size before cleanup 56. Final array after the cleanup is now 37, so that's a nice improvement. So I'll show you that now, the final array. We'll just clean up that data a bit. It still hugs the sides, as you'd expect, because it's constantly trying to find the quickest way to the final destination. So as you'd expect, it's hugging all the edges, going around places until it gets there. I've got a better way. If you're doing a lot of twisting and turning around places, especially for flat areas, it's particularly good for, but you can use it in a lot of places actually. It's using main guide paths So it uses localized guide paths on its journey from A to B. So it'll help it curve around things and look more natural way of following. Instead of hugging the edge around things all the time, like hard hugging the edge, it'll do a more natural curve. I'll show you that now. So I've got here, so 30 degrees works out. So when you're creating the nodes, the maximum seems to be around 40, somewhere there. It works pretty good. But when you're doing the actual get the path, about 30 works out pretty well. So with this API I made, I've got an ability to use main guide paths. So you just add an extra parent node at the end. See that? Guide paths. You just get the main folder node that has all these path nodes in it and send the node through. It's an optional thing you can send through. So something like here, you've got a folder. I'll turn that on so you can see it. So these are these are manually placed guide paths. You don't have to put many. There's only like 6 or 7 or 8 of them. There's really not many. Very easy to do. Knock them out in a couple of minutes. Just put them in very middle central locations where in a general area you would, and if you're moving in a general area from that general area in this way forward, because you can because of the mountains either side, you put it somewhere in the middle down the low point as you're heading out of that area. Same again here, it's like a central area, so it'll sort of cover this general area here, this one. And so when you're going over this way, you're going to have one at the entrance somewhere, and then further down. Same with this way, it'll go either this way or go around that way. So there's that one there, there's another couple down that way as well. Okay, so there they are there. You can call it whatever you want, the name doesn't matter. The name of the folder doesn't matter either. You just send through the node of the parent folder and it will go through and find the ones that are appropriate to use. And I'll show you that now. So this works really well. So this mixes the automated nodes mixed with a little bit of manual placement. The combination of those two things ultimately really works the best. Okay, so here we are. We run it. It's created the automated little pathing green nodes, and then you've got your manual big red boxes. The height of these boxes, it really doesn't make any difference. It's not the vertical height that it gets calculated, it's just the X and the Z coordinates. The Y coordinate is irrelevant for this for these main guide paths. Alright, so instead of hugging the edge of the mountain trying to find the quickest route, it'll now use the next destination, one of these guide paths instead, to help guide it around things. So this is actually a much better method. So we've reached main path ID 0, that's the first one. It's just guiding its way through towards the second one. There it is, reached main path ID. The path ID number is not really relevant. It's you can put these main paths in any order under the parent folder, going in any direction. It really makes no difference. It'll only select the ones that are within this box area, well, the green dots, that whole area where the green dots are, any that are in that area, it'll look at that, unless, like, it'll look at that one, and that one, but it will not use this one. This one is further away from the destination than this one, I think it is. So that one there is ignored, but all the other ones are used, as you might expect. So you'll see that now. So we're now tracking towards this one. All right, reached next path ID, whatever. ID doesn't really matter. It does a little bit of a, it's not a straight line, but you could smooth that out in your final, when you finally have all the finished path cleaned up and everything and smoothed out, you can even smooth it out more with, you could average out the next two paths, or just skip one and go to every second path. That'll be a little bit smoother, so you get less jumping around. But for the sake of performance, I've limited the number of little green dots everywhere. You don't want too many, because it will take longer to run every time you do it. So it's just pathing through. The next closest one it can find, whether it's in a straight line or it's in a bit of a little janky sort of a angled, but that'll get cleaned up in the next cleanup phase. That'll get cleaned up. It'll look a lot better anyway, so don't worry about that. So yeah, see, it's pathing its way around. So it's using these guide nodes now. It's a much better system actually. So a mix of the two, and boom, one more step forward and it reached its destination. So it went from 50 to 30, so that's going to be heaps better. Yeah, so you can see the other ones there, just a bit of a general placement, doesn't take long at all. Just put it nicely in the middle of a general vicinity area, of a large general area, and it will be able to make use of that. So now I'll step through that, and you can see it's cleaned it up quite a bit, a lot nicer. Yeah, so this is actually, I don't know, it's about as good as you can get it almost. Not quite, but I mean it's pretty good in my opinion. If you want to smooth that journey out a little bit more, you just skip every second dot and head to every second one. It'll be even smoother. You'll have less bouncing around, if you like. Yeah, there it is there. So that's the destination there. That's a lot better than the previous way of doing it. The other way, without using these main guide nodes, it's good for really tight spaces where you've got to wind your way around things, go forwards, backs, left and right, all around all these crazy different directions all the time to get from A to B. And that's necessary actually for tight spaces. We'll have a look at that next. Okay, so this is the, I've just placed a node, a guide path, or guide node, either way, here. And I've just put it a little bit past the point I want it to be managing, which is pretty much at that spot right here. I want it to sort of come here and then go down there. I put it past that because it'll look within 200 units of this guide path and then make changes that way, but I don't want it to make changes too early. So basically what happens is before it reaches its first guide path, it'll utilize a smaller distance in movement until it hits the guide path, and then it will make a bigger jumps in movement, so it'll be more smoother. So yeah, so those are the two methods, and you can combine them how you like, but until it hits the first one, it'll be smaller jumps, and then after the first one all the way to the very end, it'll be bigger jumps. So that's a bit of the best of both worlds. So if I run that now, it's finding the path. Found that one there. So it realizes this is the only one, so it's also the final guide path. So now it's just heading towards the end. And in the cleanup phase, it'll make bigger jumps between the little red dots here, so it'll smooth it out much more. Okay, so you'll see that now. 23 to 14, that's quite a simplification. So let's just check that. So still want to have all these little ones. Yep, that's turned out pretty good. Goes over here, goes over here, goes over here, bit of a shortcut, and then going over this way. A little bit of movement there, not too bad on the whole, and then go around this way. So there's the path there. It's not bad, it's not too bad. So totally, it does work. It does work, but in some cases it might have a little bit of trouble getting every little tiny path movement in the start phase before the guide nodes. It's not necessarily gonna, like if there was another one instead of here and it was just sit there between these two, it would have found that and it'll literally just walk straight over the top of that. Not ideal what you want. That doesn't generally happen, but in some minor cases it might do things like that, but not very much. On the whole, it actually works pretty good. And as you can see here, it's worked out a nice path, quite good. Maybe not perfect, but pretty good. Yeah. So yeah, so in tight spaces I wouldn't use these guide paths. I'd put them at the start of an open area where it's easy to work through. So you might put one just there, and say right in the middle of this little area here, you might put another one there. If you're going over that way, you might put another one over here. If you're going over to the other way, you might put another one over there. So it'll follow the most closest next guide path in its trajectory towards the end path, basically, is what happens. Yeah, it works pretty good. Yeah, so I've designed all the code to step through one spot at a time, but in the final API release it won't be doing that. It'll just be the final path completed and done, and then another API, what you'll have is just give me the next path, x and z coordinates of the next path, possibly the y coordinates as well, and you can just keep changing that index of an array that's held in the core game engine C++, so it's just sending that through each time. So you get to this start and you get to this path, you get the first one to start with, then you go here, then you just ask for the next one, and then it'll go there, that type of thing. And you do it just within like a certain distance of getting to the next path. You ask for the next position to go to, and then send the player there basically, and keep doing that. So it works pretty good. Yeah, so I put these guide paths. The placement of these guide paths has worked out for me quite well, just as a test. So you go this way, then you go this way, somewhere over here. So it's just from the. So in other words, if you're going around that way, you want to have. Probably don't have to put that one there in the middle there. It's just the one in the further down. It would still go straight ahead towards it actually. But yeah, but if there was some sort of curve here, it needed to curve around it. It would be better to have one. Anyway, so you've got one here just for the sake of it, and another one there. I mean, theoretically, I could put another big red one here somewhere. It's generally used for open areas, the big guide paths, frankly. That's where they work best. I wouldn't put them in tight areas where you've got to sometimes backtrack and go backwards and around things. It could be something like this. Okay, let's try another one last one, and so you can have a look at it. Okay, I've got another one here. A little test going from the blue to yellow. So there's a few paths here selected before and after. Now those guide paths, the big red boxes, they're outside of the scope of right on the edge. So I won't use ones that are right near the edge. So there's the guide paths. Actually says it's 0, so they're not used. If I wanted to use them, I'd just put them in closer towards the actual path that I want to go. Like that one's relevant, totally. That one could have been used if I pushed it up a bit further up towards the, a bit further in a bit. They would use that then. But for now, I'm just going to see to get from A to B. I won't be able to go up here. Eventually, it's a bit too steep. You can change the angle, of course, and then it will work its way up. But once it gets up to about here, it's not going to be able to cross that, no matter what. So there's no path, ultimately, anyway. But yeah, I mean, so anyway, I've got it at 35 degrees. The maximum angle created on start is 40 degrees, and I'm using up to 35 degrees of it. I need that extra 5-degree leeway, just in case there's a just impossible path that can't find a route. It'll push its way through and try and complete it that way. Okay, so we step through that. Local guide nodes about 350, down from 240,000, so that's a bit better. Takes a bit of a jump, but it has found the next closest distance within a certain maximum of 280. 280 is about right, somewhere there. 250 to 300 is a pretty good number to put in as a maximum amount, and that's actually, you can adjust that in the API when you run it as well. Yeah, so it's going to try, by nature, try and go up here because it thinks, oh, that's closer to the destination, but it'll soon find it's too steep for 35 degrees. Go up there. No, can't get to the next one because it's more than 35-degree climb. So yeah, so that's limited in our little query. So it'll work its way backwards now. Yep. So it's found a path. No. Okay, it's come back to here. Yeah, it'll just keep going. As you'd expect, it'll sort of hug the edge a little bit because it's not using the guide paths. Had I used that guide path there, it would sort of head straight for this guide path. So I mean, theoretically, I could stick it up here in the corner. That would use that then. It might actually be better. So it's working its way back. It's a little bit towards trying to find that, because it's always trying to head towards, without the guide paths, it's always going to go head towards that, the end destination as its final route, as its next end position, unless you use guide paths, in which case it'll use the next guide path in the route. Okay, so it's no path, revert to last path. Okay, so it's gone back again, which is fine. Yep, works its way around. This one works pretty good. I had to do a lot of tuning and adjustments to get this particular one to work nicely, because I ended up having to add more code into it already, which was already a lot, to sort of a collision check between the current node and the next node it's looking at. It's not really collision, it's a change in height. So for example, you want to go from this node to that node, well, it's not going to be able to, even though the height difference, the net height difference is not much. It's got a gigantic thing in the middle. So what I've done is I've done a check to see, look at halfway between the next path that it's looking at, and look at the height difference of that middle position in the terrain, and if it's above a certain level, then don't go there, because it's you're climbing over things. You don't want to be doing that. So that made things a lot better. Once I put that in there, you can see it'll work its way closer. Now this node, you would expect it to probably go there, but it won't be able to, because it's above the limit. In the middle of those two nodes is this lump of dirt, so it's actually looking at that and it won't go there. So instead it's going to either go here or maybe there, even though that's at a little bit of an angle, the actual slope. So it'll go there instead, and then the next available path will be that one. So from here, it says there's no path. Obviously, it's not. It doesn't want to use that one. That must be, the slope of the angle must be more than 35 degrees. So it's not going to even look at that. All right. So okay. So it's adjusted its maximum movement distance. So to 330 and a maximum angle of 40. So now it's found the next path. Yep. Okay. So might have been the. Yep. So yeah, it's coming at a different angle. So when it wouldn't go from here to here, because it's found this stuff in the way. But once it worked its way over to here, now it can. So there's nothing in the way. So that's good. Actually, it's like a collision check in a sense. Of it, just of the train only. So, yep, all looking good. Decided that one was a little bit better than that one, for whatever reason. But I mean, it's sort of makes a little bit of sense. It is a bit lower, so you go up here. You could, up here and then go down. It's a little bit slightly more natural approach, I guess. Yep, it's found that. Alternate path selected, probably as against that one there, I suppose. So yeah, it's I don't mind if it highlights in red a few more extra paths along the way. This is in the discovery phase, because it just allows the cleanup phase to have a better cleanup. That's it, basically. More paths to select. It'll choose the best one. So it's not really an issue. And it runs super fast, so it'll be right. Yeah. So it goes from here to here. Yep, there to there. It's decided that going over this way was not optimal. Too much of a big mound of dirt in the middle, which is fair enough. And this one, bit of a drop off. Too much of a drop off just there. So it's going to go up here. It'll probably go around here and then here, Yeah. Yep, that one, and then switch back. So that's finished. That means it's gone straight to the end destination, the last one that was just here. So we started with 43 total nodes. It's cleaned it up. It's down to 28 now, so that's a lot better. And I'll just path through that one at a time. So this is the cleanup. Not too bad on the whole. I mean, yeah, I mean, I wish it would have probably gone a bit lower. Doesn't have to climb up the cliff face. I mean, if I use this path node, it would then, this little path part would look a lot better. I might try that. Okay, so pathing around still. So that looks pretty good. Going up here, going up there, this way, this way. It does cut back here a bit sharply. Not much I can do about that. It's going to occasionally, things like that will occasionally happen. Because there was no other node, say just for example right here, there was no other node to choose from. So that was the best option it had to choose from, so it just took it, even though it's going up the side of this little mound a little bit. That's not perfectly optimal, but it's not too bad. And then it's just working its way towards the end. So yeah, so that's not too bad. We're going over a little bit of dirt there, not too bad on the whole scheme of things. Yep, okay, so I go up here and down here. Work our way around and up, okay. Yeah, I mean, you can always smooth that out a little bit. You look at the next two paths ahead and probably take an average if you really wanted to. It would be a little bit more, and then obviously you don't need to go all the way to the end of the node. You can, within a certain distance, say 100 units, 200 units, change over to the next one. It'll smooth the movement out as well when you're seeing it in actual real life, in the game that is. Alright, so it's discarded that last one and just went straight here. There is no mound or height checking between the cleanup phase. I suppose I could add it into the cleanup phase as well, so because there's a bit of a drop there. So in other words, it would force it to go to there and then back over here. It's something I could do. But otherwise, it's pretty good. Works pretty nice. Yeah. Okay, I've just moved the main guide path a bit further up to sort of lead it in a slightly better way at that point from the starting position. So it's got guide paths available 1. So now it'll sort of stick to heading towards that guide path. So it's actually more of a straight line. So it is better to use these guide paths actually, but definitely. And it switched directions just before it got to the guide path, and the rest of it will be it should be identical to the previous way of doing it. And I'll just clean that up. So 37 down to 29. Just check it. Have a look at that. Yeah, it's a lot more of a straight line. A lot better in that regard. Yeah, I mean, you could argue it needs a few more guide paths to have a slightly more accurate route. It's not too bad. I mean, you wouldn't do a 90-degree angle, but you just, before that you get to that, you would change to the next one anyway. So you're not going to always, you wouldn't want to go to the exact position of every single node. You sort of switch to the next one before, within a certain distance. It'll just smooth that out, come up around here, same as before. A little bit of a jump cross country there, tiny bit, not too bad. Up here, up this way, over this way. Exactly the same as before, no different. Yeah, so there it is there. Comes up, okay, drops down a bit there, that's the only thing, but it's not too bad. Yeah, so that's, I think that's done for now. I've spent a lot of time coding this up. I would say this is the hardest thing I've ever coded myself, actually, on anything. This is harder than AI, like enemy AI. That was difficult, but this is harder. Yeah, I think I'll go back to doing enemy AI any day. It'll be more enjoyable. Yeah, so anyway, trying to get maximum performance and a reasonably good path. There it is. It does work. Okay, guys, it's finally done. So on start, before first drawing, just all you need to do is get the node of the terrain, and then run this API. CCB create terrain pathing, send the terrain node through, and whatever angle, maximum angle that you want, that's possible to get to, which is generally about 5 or 10 degrees more than your normal default walk angle, maximum walk angle. And then, so first drawing, do that, and then so that's run once only, and then during the game, anytime you need an updated path, you run this one with the updated start and end position. All you do is get the node of the start and the end, get the position, start pos, end pos. You can just send it through, and then also if you want to use guide paths, you'll need to send through the node of the parent folder, parent node through. It's an optional extra, that one at the end. You don't have to put that there, but it's optional. And then just run this get terrain path. There's the terrain. You've got to send through the terrain. There's the start pos. There's the end pos. That's a vector 3D. You don't need to set up a new vector 3D. You just send through that. It already is a vector 3D. So that's that one. So and then the maximum default walking angle, path angle, maximum default movement distance. Somewhere between 250 and 300 is typically a pretty good range. Here's typically around 25 to 35 is pretty good range as well. Actually, probably closer to 30 is better. So you might even go up to 30 to 40, somewhere there. And that's the parent node optional extra. So when I press P, it'll create the path. Now, once the path will be created, you don't need this, won't show anything unless you want to see it. And then that's another API. It's called CCB show terrain path. And all you do is send through the node of the terrain. That's all you've got to do, and it will show the terrain path. And it will use the highest texture that you've got for the high mountains or whatever it is, whatever that is. In my case, it's well, I've set it to red, but actually I'll change it so it looks at the last texture. So and normally it'll be whatever. You can add a new texture color for that purpose only, or it'll just use the last one, which would like something like that, like whatever the highest texture. You might only have 3 textures or 1. So if you only got the 1 texture, well, you're not going to see it. But anyway, so yeah, so got that, save that, and then all you do is run it in debug. Alright, so here's the pathing nodes. So I've got it on startup. It's already created all the path nodes. Doesn't take any time at all. And then when I press P, boom, instantaneously done. Super fast. Local nodes. It's telling me that between the start and the end, there's a total of 347 nodes, and it's it's done its usual checks. You just can't see it. You don't need to see it unless you really want to. Path is complete. That's the main thing. It's telling me that there was one guide path available, which was that one. And so if I press S now, which will run the third API to show the path, boom, there it is there. It'll just do that in one step. Instead of stepping through it one bit at a time, it'll just show the whole thing. It's a lot quicker. And that's the same as before. Yeah, pretty good. So that's done. Let us know how you go with that. Any issues, any major issues, you might need to send me through the file you're using for me to test it out and work out what's gone wrong if it's not you're not happy with it, and I'll take a look. But yeah, I think that's it for now. So I hope you like that. Let me know what you think. Cheers.